Hi, welcome to another parametric house tutorial, and in this one we're going to talk about Kangaroo plugin, how you can model this tensile structure. You can see that I'm going to convert a simple rectangle with 4 points at the corners and with 3 curves and produce this tensile structure. We can also increase or decrease the number of the divisions of the mesh. You can see that I can run it again and get the final results, and we can also control the overall of the shape by changing these control points. So if I just change the control point of this curve, you can see that I'm getting different results, which is really easy if you want to get different shapes from this algorithm. This is going to be a good explanation of how you can use Kangaroo to get a tensile structure. But before we get started, if you're new to our channel, welcome. Consider subscribing because we have weekly tutorials, and you can also, if you're new to Grasshopper and you want to learn how to get started, you can watch this tutorial up here and learn how the basics of the Grasshopper works and get started. Okay, let's get started from scratch. And what I wanted to do here is to explain, first of all, let's just start with a simple rectangle here. And this is the base mesh of the Kangaroo tensile structure. So what I want to do here is to make it as easy as possible. So I'm going to just skip some of the parametric ways we can do that and make it easy to understand. So I'm going to just click on single points and draw a point in the mid of this one and this edge. So after I run the tensile structure, it's going to actually have an anchor point here. So these points are going to be the anchor points of this edge, and we need these two midpoints. You can also maybe move them on this edge. It's not really that important, but remember that you have to have these points to get the anchor points. The next part is to draw 3 curves. So if I want to control it, I'm going to just click on control point curve and click on here. I'm going to just click 2 points on this edge so I can control it later. For example, if I just click here, here, and then at the end, what's going to happen is that this line is going to have 2 control points, and this is going to help me to move the control points up and down and get the final results. So remember that you can simply just draw a curve, a line with 2 control points by clicking on the edges. Let's just make a copy here on the let's just select that, make a copy at the mid and again at the end, because we need 3 curves to control the tensile structure. And if you want to just deform that, you can simply maybe select these points and move them up. And if we want somehow a symmetry in our structure, I'm going to just select both control points of this curve, and for this one I'm going to move this one. Okay, and we're going to get started with this simple 3 curves and a rectangle with 2 points to get the final structure. Let's get them inside Grasshopper. I'm going to put the bifocals plugin so you can see what I'm doing. First of all, we have a curve, and I'm going to put that to set multiple curves. Select these curves as the base curves. Okay. Another one we need here is the rectangle. So I'm going to put this rectangle also inside. And next one is to work with Kangaroo. Okay, the Kangaroo plugin here is really easy. We have the, let me just make this a little bit bigger. We have the main part, which is the solver, and we have to pick between these different solvers: bouncy solver, soft and hard solver, step solver, zombie solver. We can use the bouncy solver. The bouncy solver is going to give you somehow like an animation to your project, but the solver is going to just give you the final result. So I'm going to just put the solver here, and let's go and give the goal objects here. The most important part of the Kangaroo plugin is the goal objects. What do you want to give this physical forces to, so we have to define the goals. Let's first start with the base, which is going to be mesh. We have talked about the Kangaroo plugin. I'm going to put up some videos up here which you can watch, which is related to the Kangaroo tutorials we have in this channel. But for now, what I want to do is to make a simple mesh. So I'm going to go to this mesh tool and utility and select this mesh surface. The reason I'm using this mesh surface tool is that it's going to, when you give it a curve, it's going to convert that into a surface. So what's actually happening is that, first of all, it's going to convert that into a NURB surface, which is simply this NURB surface. And then it's going to convert that into a mesh. So this is a way you can just connect a curve to a surface. Then you can divide the U and the V count. Let's give this a number slider, maybe from 3 to 30. And I'm going to delete the title. Give this to U count and V count so we can control that. Okay, the V count is really important because let's just zoom here. You can see that when I put that into an even number, the edges of the mesh is going to sit on this mid vertex. So remember that you can't give that an odd number. We can just double click on the V count and say that we need an even number. That's actually because we have a symmetry on our project, and to make it easier, I have chosen the mid edge of the both parts. Okay, and now we can also give this a division. To make it faster, we can even decrease the number of faces, so the result is going to be faster, and then we can increase it at the end. Okay, what we want to make the deformation is this mesh, so I'm going to go to the Kangaroo plugin and use this. In the main section, you can find it here, show. Remember that when you put show onto a mesh, that means that you want to see that as an output. So as you connect that show to the goal object, if I go to the output here, you can see that we have this mesh as an output. That's exactly what we need, and the deformed mesh will be as the output. The next part is to select a tensile structure for this mesh. It's really easy in Kangaroo. You just have to go here and in the goals mesh section, which you can give different forces to a mesh. The easiest way is always selecting edge length. We have that in Kangaroo physics when we had to just select multiple components to make this, but this is really easy. You just have to give this an edge length and give it to a mesh, and what's happening is that it's going to try to convert all of these edges into a spring, and then you can give it a length factor. So by default it's a 1, which means that these springs they can't deform. It's just like the length of the 1 of the edge length. I'm going to give it from 0 to 1 with 2 decimals and delete that so you can see the input. Okay, so that is the length factor. Now what we have here is to just use a shift key to add it here, and let's just click and have a button to see the reset. If I click on the reset, you can see that this tensile structure is just trying to make it smaller. You can see that it's just, oh, let me just put that. It's trying to use those springs to make a tensile structure, but we don't have any anchor points. So for example, just to understand the basics, if I give an anchor point, which is going to be in the point section, and anchor, it's really easy. And let's just give that. For example, if I give these 2 points, use the shift key to that, you can see that the tensile structure is trying to get into these points. And if I give a series of points at the corners, the result is going to be interesting because, okay, let's just turn everything off. And as you can see here, when we connected the edge length to the goal object, the output is going to have 2 set of groups. The first one is like 0, and then it's 0, 0. To make this easier, I'm just going to flatten the goal objects because it's going to give all of the goals in one group. and it's easier. And remember, if you don't know about flatten or graph, you can watch this video. We have explained this. We have also a complete section on data management on our course in powercourse.com. So I'm going to just flatten this, and as you can see, the output is going to be a mesh, then a series of nulls and lines, which is the line of the mesh. And what I want here is just the mesh. To extract that, we can go to the sets and pick it up with a list item. The index by default is 0. Now you can see that it's easy. Let's just increase the number of divisions, and here you can see how easy it is. By changing the length factor, you can see it's actually giving a relaxed mesh to the base mesh, which was a simple mesh surface of the rectangle. So you can see how easy it is to make a simple tensile structure in Kangaroo. But now what we need here is these 3 curves, which is going to help us to bring this up and confine it to these curves. I'm going to go to the Kangaroo plugin. This time it's going to be a really great tool, which is on curve, goals on curve, and let's just bring that down. This is really important. We have to define a series of points and say they have to be on this curve, okay, and then give it a strength. To make that, first of all, the curve is really easy because we have just made that into a curve component, so I'm going to give that to a curve. But what about the points? The points is really important, and we have to try to give this point the correct answer. So when I just selected these curves, the set multiple curves, I selected this one, and this one, as you can see here. Now I want to find the points on the mesh. Let me just show you the base mesh here and turn this off. And it's really important to give these points on the mesh vertex to bring it up on the curve. A technique I have found is really easy is to go to this curve tool, select the start and end, the endpoints tool, which is going to give you the start and the end of this curve. Okay, then I'm going to make a line, which is going to simply connect the start and the end with a line. That's really easy. Actually, we're going to make this curve into a simple line there. And then what I want to do is to divide that line into the number of divisions. So if I go to curve division, divide curve, let's just find the division we had here in the U count. So I'm going to give that number here to the count, and that's it. You can see how easy it is. These points are sitting on the curves, and then we have to give that to the points. Okay, the first important part is that when I give this to a division and we have 3 lines, it's going to give you 3 groups. Here you can see that. 3 groups of 18. That means we have 3 groups of data, which is actually, let's just type this down. This is 0, and this is 1, and this is 2, which you can see here. That 0 is not really important, it's just structural parts in Grasshopper. Then it has 18 points, so it's like maybe 0, 1, 2, 3 till the end. And the problem here is that this is 3 groups, and I just simplified that to make that. You can also simplify it here, so you can see the output. It's going, those zeros are gone, and we have that 0, 1, 2 group. Okay. The problem here is that this curve is not in group. How can we fix that? You just have to graft this curve. It's going to put each of those curves in one group, and then we will have the groups here. And you can see that both of them are okay. Let's just simplify this. Again, let me explain. So you can see that we have 3 curves. Each curve has 18 points. And for the input of the curve, we have to also have 3 separated groups. And you just can simply do that with a graph. If you don't know about graph and flatten and simplify, you can watch that tutorial we had in the channel. Okay, now what we have to do is to add this also to the goal object, turn it on, turn everything off, and click here. You can see it's trying to give you the curves. To make it even better, first you have to increase the strength. So I'm just going to put that to 12 maybe. By increasing the strength, it's trying to give you something near that curve. It's near that, okay? By changing the length factor, you can see that it's going to give you more tensile like structure. And to even make it better, we have to increase the number of divisions. So I'm going to increase the divisions. And remember, when you increase the divisions, you have to just reset. And that's it. You can see that it's even getting better. It's getting close to the curve. Let me just increase that. And that's it. So if I want to deform this, I can select these 2 points, bring them a little bit up, and maybe these 2 points, and scale them. It's really cool. If I want to deform this base rectangle, there's also another way on which I'm going to explain now, which is select everything, the curves and the rectangle, and I'm going to use the cage edit tool here. Cage edit, I'm going to use a rectangle to make the control points on this rectangle, and let's just draw that. 2 corners, it's going to make a rectangle. And now the U count and the V count of the divisions, maybe we just need 4 in the U direction and 3 in the V direction. The degrees is like 3 and 2. I prefer to put it 3, but it's not really important. And just right click, again, right click, and then you have some control points here. And it's really cool because if you just select the points, also the rectangle, and deform it, you can see it's going to give you something like that. Let's just move that a little bit forward. Maybe I want to deform these control points and make this a little bit bigger. And we just turn everything off. You can delete the cage edit, select it and delete it. And even maybe scale everything in the X direction. Let's just go and restart the simulation. And that's it. You can see how easy it is. You can even select the control points, select everything, scale it a little bit down. But remember, the curves is not going to go inside, so you have to just move that right hand, which is not really good, going to give you a good result. So that's why cage edit is better. So let me just put that here. Maybe we just want to move these control points. When you deform the shape with cage edit, you can see it's going to give you more control points. So that is going to give you more control on the edge. And if you want to fix that, you can simply just go here, select these 3 curves and rebuild them with 4 control points maybe. And now I'm going to select the control points. You can see how easy it is. And maybe we just want to bring them a little bit up. And that's it. That's how you can make the mesh. And this is great. You can always play with this number. Remember that you can change the tensile structure a little bit by moving the length factor. You can also decrease the strength if you want a more relaxed kind of mesh. And if you increase it, it's going to be more accurate. And it's going to finally give you the mesh, which I can bake here. This is really great. Just a little bit of a trick you can use here for those who have watched this video till the end is to use the Vivid plugin. And I prefer to use this frame tool, picture frame tool. combined with the window. I usually give that the same number for the distance. You can see it's just giving you a thickness like that. And then you can make it a little bit thickened with a thicken tool. I can bake that into layer 1 and bake that into layer 2 and have that in Rhino or something like that. That is really cool. And this is the tensile structure you can get by using the Kangaroo plugin. Okay, I just deleted the windows, so the frame is also something you can get for a structure like it's a combination of a tensile structure and maybe a shell structure. I hope this tutorial was useful. Remember to subscribe and like this video so more of our users can watch it. And let me know in the comment sections what do you think about this tutorial. Hope it's useful, and see you in the next video. Bye.